Avatar is 2, therefore Jurassic Park is also 2 because they are also the same. Same in some way. That is another kind of collaborative filtering. So essentially what collaborative filtering does is it uses the intelligence of a mass, a group, to infer the expectations on an individual. Okay? There are several ways of doing it, broadly divided into what is called neighborhood methods and what is called matrix factorization based methods. These are two of the big chunks that fall in it. Neighborhood methods, as I just pointed out from that toy example, will either find out users who have given similar ratings or expressed similar tastes to yours based on the ones that you have both rated. And then it will find the rating for the one that he has rated, you have not, and impute his rating onto yours. Of course, it's kind of a bad idea to do it based on one person. They will probably do it on a bunch of people and take an average and whatnot, right? Same thing works for items as well. Items being movies in that example, where you find similar items, be it by genre, be it by actor, for the case of movies. For the case of products, it might be laptops having the same configuration, whatnot. And there you find the rating of that, and you put the rating of that into this unknown products, right? Latent factor-based methods, this is what matrix factorization relies on. This is a method which was first brought to the forefront by that same Netflix competition that I just alluded to a few slides ago. It was a very interesting idea where they said that the rating matrix, we are going to visualize it as if it is a product of two matrices. One matrix that is specific only to users, okay? It has the users, the three people over here, and some attributes that describe them, some vector that describes them. The same thing we do for the items. In this case, the movies, it also has the same number of attributes. Now, in reality, these latent factors, as they are called, hidden dimension, they don't have any physical interpretation. But just for the sake of understanding it, what we might think is, you take a movie and you say, how much action content does it have? How much thriller? How much romance? You put it at like percentages. And then you take a user and you say, hey sir, how much do you like action, romance, etc., right? So they put down their own percentages. And then if you do a similarity measure, whatever similarity measure that might, Euclidean distance, dot product between the two, whatever, right? And the basis of which, if they align very well, then you get a high rating. If they misalign, you don't get it, right? So it's saying that this number over here is basically the dot product of the feature vector of this user and the feature vector of this movie. So it's basically you're factorizing this matrix out. And that's what I have formulated over here.
I have a question.
Yes.
So if you can go back to the toy example that you gave. So I understand Avatar, I understand Eagles, Jurassic Park. Citizen Kane. I see somebody who has liked Jurassic Park also likes Citizen Kane or Avatar. Don't you think it's basically like a little bit of bad imputation?
So I think what I would say is that people have multifarious tastes, right? In the sense that, it's not like you are bent on one genre and one particular item alone.
Yeah.
You have one dimension to you, and there might be another different dimension.
Yeah.
These kind of things are, as you can see, hard to catch over here, and it looks like an anomaly. Yeah. But when you go, for example, the matrix factorization route, and when you see the feature vector, you see that there are high values at some part of the vector, and somewhere down, the values go down, and again they rise up, corresponding to something else in the movies, right? So there they align with something else. Does that answer your question?
Yeah.
Sure. Why am I stuck? Okay. Right. So I just went over collaborative filtering. Let me extend that to model-based methods before I hand it over to my colleague. So the essential idea of collaborative filtering, one idea was that you use the intelligence of the masses to blah. There is another way of looking at it. What it's essentially saying is there is such a thing as a user model, just describes the user. There is such a thing as an item model, just describes the item, right? If you combine these two, you come up with a representation of the expectation, how well a person is going to like a certain item. One way of doing that was using the ratings. There might be multiple ways of doing that. A user might have demographics, an item might have things like price and color and availability and configuration. So what model-based methods did is that they took extension of this concept of collaborative filtering, and they said we're going to use other machine learning techniques to basically marry this user model and the item model together to come up with the final recommendation. Obviously, various kinds of algorithms have been tried. When you say machine learning, people get very excited. We'll do everything, starting from logistic regression all the way to whatever I can. So naturally, people have tried lots of things. One of the things that have been particularly successful in this regard is the use of restricted Boltzmann machines, and I'll invite my colleague Karthik to talk more about it.
Hi. I see half of you are dropping your heads down. So let's play a small game. I'll explain the game first, and if anyone is interested, just walk up to the stage. I need just one person. So a lot of you must have heard about this game where you think about a famous personality, dead or alive, and there is a person who's asking questions, and the person asking the questions would guess the person you're thinking in your head within 20 or so questions, right? Does anyone want to play that game? Yeah, come on.
No, actually, I'll get the mic to him.
Yeah, sure.
So you don't have to wait.
Okay, so
I guess the character?
no, so you think about a famous personality in your head, a very famous personality that everyone is aware of. Don't say you. And dead or alive, right? And I usually trust humans, but I trust data more. So can someone write up the name on the board so that I don't see it?
Oh, write up the name.
Yeah, just write the name that you have in your head. Okay. I hope I don't.
I recognize the name. So.
You're, oh, okay. Okay, while he writes the name, let me start with the questioning. 20 questions, right? Someone keep tab of the questions. Is the person dead?
No.
Is it a male?
No. Sorry, yes.
That's confusing. Is that a hint? Yes. Yes? Okay, you didn't get the joke. Only 2 questions over. Okay, so is it an Indian?
Yes.
An Indian female who's alive.
Male.
Oh, Indian male who's alive.
Actually, not Indian.
There's a controversy on it.
Is it Mother Teresa?
Let's say he is famous for.
Oh, it's a he? Oh, it's a he?
There is a controversy.
You want to change the name, personality? No? Okay. It's a controversial identity, right? Oh my God, that's tricky. Okay. So 3 questions over. A person whose nationality is in controversy and it's a male. Alive. Is the person famous in arts, sports, or politics?
No.
Social service?
No.
Okay. This is not in the questions. He's a famous personality, right?
Yeah.
Okay. Okay. By arts, I mean like music, movies, dance, anything, right?
So just show of hands. How many of you know this person?
Everyone.
That's
Wow.
how famous.
Okay. Yeah. Okay. No. Don't give me any hints. Okay.
Just yes or no. Yes. Just yes or no. External.
Okay. I got some external noise induced in this, so I'm going with it and asking the next question: is he a gangster?
Yes.
He is a gangster, a mafia kind of a person, right? Yeah.
Type of.
Type of. Okay. It's too noisy. Okay. So, is he from the Indian subcontinent, or does he live in the Indian subcontinent
Presently?
presently?
Yes.
Yes. Does he live in Pakistan? No. Okay. He's a gangster who might presumably be. Is tricky?
Is noisy as well.
Is noisy as well? Oh my God. Okay. Presumably a gangster, presumably an Indian. Is he between the age range of 40 and 60? Around there, not the exact age, around there?
More than that.
No?
More than that.
Even that is confused. Oh my God. This is like super noisy.
More than that.
More than that? around the 70s. Okay, how many questions are over?
I'm starting 9, I think, right?
9?
Okay.
10?
9, I guess.
Okay. What else? Has he been, oh, he's still alive, right? Okay. So is he from Nepal? Is he, was he in the jail and he fell in love with a reporter? Okay. Okay, so how many questions did it take? What process did I use here? How did I go about it? Was it elimination?
After knowing the gangster, it was
Yeah, right? So, next slide, please. Okay. Okay, this is the only slide I'll be using. So, whatever I did right now is what these things do. Restricted Boltzmann's machines, right? So, okay, so what process did I use here? I first have information from someone, right? I have information from someone which I don't know, right? But I had someone else who was there to corroborate that information. There were a lot of parameters involved in Sobrach, right? There was his nationality, which is confusing. There was his age, which is confusing, and his profession, and his claim to fame, so on and so forth. There were so many variables involved in it. What did I do? I took every variable one at a time, right? I subsampled the features.